Hello, fifth grade. So for those students who may not have the lenses, we are going to do a lab today about refraction. So if you read along in the book yesterday, we learned about two different types of, well, we learned that light can be refracted. And refracted, if you highlighted the definition in your book, means we can bend it. For those of you who wear eyeglasses like I do, you know all about lenses and making light do different things. There are two specific kinds of lenses. There are, I don't know if you could see those, maybe I should get a darker, something darker on there. Here we go. There is a convex lens and there is a concave lens. Concave means that it caves in. You can see the shape, that it's thicker at the edges and thinner in the middle. And convex means it kind of curves out. The most common kind of convex lens that you might be familiar with is a microscope. And if you had a tissue, if you happen to have a microscope around, you could take a tissue and you can actually feel that it's curved, that it's thicker in the middle. So both of these types of lenses refract light. And our lab is going to talk about like how they affect light. Now, the first thing it says is to record your inference, which is what you think of how a lens affects the light of a flashlight shining on your screen. So let me see if I have a flashlight that's working here. So we have this little white dot here, and we're going to see, and I think most of you might know what happens to a light. I don't know if you can see that, but I'm trying to think of how I'd be able to do that from the side, but it seems to be focusing the light, and it gets really from out there to a little sign right there. If you kind of look right in that area there, I'm going to try to stay in that box, that it seems to focus the light to a specific point. And then a concave lens, and I'm going to use this one because I could use this one, I guess. You can see right there that it sort of makes the light look, the lines on the paper look, I don't know if you could see that that caves in, but let's see what we can get happening there. It's really hard to, it's not like a big difference, but the concave spreads it out. So I'm going to go ahead and write that down, that a convex seemed to like focus the light to a point, and the concave lens spread the light out. Number 2 says, record your observations of the image made when the light from the window passes through the lens onto the screen. So I am going to try to tilt this. I don't know if this is going to work. I don't know. And we'll see if it goes, I don't know if it goes that way. I don't know if I'll be able to show you this online or not, but I don't know if you can see the outside on that. You could actually see it actually projects, but it's upside down. I don't know if you could see the clouds there. Maybe if I were to run and shut the room lights off, that you would be able to see what's outside. Let me see if I go, is on that paper. Let me see if I can shut the lights off, if you can see that the sky is blue on there. I don't know. Here I am. I don't know. Let's see if I held this up and see if I could get on there. I don't know. Can you see that it's focusing from what's outside. If you have a magnifying glass at home and just a piece of white paper, I would suggest that you do it. It's pretty cool that if you it'll just focus there what's up above it there. And the unusual thing is that it will be upside down. So I wonder if I use this one. I don't know if it'll give me what's on there. No, it probably won't. Now this one, since it spreads the light out, I don't expect to see anything clearly. I see light on there, but so record my observations. So I saw what was outside the window. It was upside down. So the blue sky is on the bottom and the green grass is on the top. It was upside down. Okay, and this one I just saw like unfocused. It was unfocused. I didn't see really anything. And number 3, it says record what you see when you raise the lens slowly from your textbook. So let's take this, and as I go slowly upward, you can see that the print gets larger. So it must be bending the light for me to see that a little bit larger. So I'm going to say under convex, the print looks larger. So if you take a second, what do you think is going to happen when we take the concave lens? So here the concave lens is over the print. So what's going to happen as I pull it away? Don't know if you could tell, but what's happening to the print? It is getting smaller. So the print gets smaller. And then you can turn it over here, and it asks you to actually make a sketch of a convex lens. So the convex lens is thicker in the middle. So you're going to think you're making two sort of Santa Claus bellies or something like that. Maybe it looks like an almond. And it says include how it affects light rays. So let's think about the light rays coming in here. And if you go back and look at what you wrote, you said that it focused them to a point. So in this one, it focused them right to this point, and that point is actually called the focal point. So if you sketch a concave lens, remember the lens that's wider at the top and at the edges, and it sort of caves in. So maybe it looks like a capital I guess. And if we're looking through it, or the light waves are coming this way, it's very unfocused there, so it's kind of spread them out. So I could see light here, but it was very spread out. So how did the appearance of the beam of light change for each lens when you moved it back and forth at the beam of light when you were going there? So we could say the convex lens focuses the light, and the concave spreads it out. Describe the image you saw on the screen as you held a convex in front of the window. What was unusual about it? I just really wish I could get this to work for you through the window, but I can. So if you happen to have a magnifying glass, even somebody's eyeglasses, my eyeglasses, I can't see, but if you look as I pull away, as I pull away, the writing gets bigger. So maybe if you were to just stand in front of a window and shine on the screen to see what happens, what you can see on the screen or the paper. You could see everything that was outside on the screen. But what do we want to ask? What was unusual about it? It was upside down. How does a convex lens affect light when it focuses it to a point? So we're going to use the vocabulary here and just say the lens refracts or bends the light. Okay, that's what we're going to be doing. I'm going to try to hold the camera up and the magnifying glass and the screen with the window behind me and see if this works. Okay, let's see here. I think it's getting busy. I'll hold the screen here. I don't even know because I can't see my computer whether it's working here. But as I'm hoping that I can see it now. I hope you can too. The blue sky and is on the bottom and the trees and stuff are on the top. So that's the best I can do right now. Hopefully you can try it at home if you have a magnifying glass. But this is what we're going to be doing tomorrow, using our refract word, so we know that that means bending light. Okay, so I'll attach this. You can pause it and try out everything, and I hope you have a nice night.